Hello, and welcome to a StatQuickie on t-tests. I work in a large genetics lab, and people often ask me questions about t-tests. The first question they ask me is what type of t-test they should use. There are two main categories for t-tests, paired and unpaired. Paired t-tests are useful when you have before and after measurements taken from the same test subject. For example, if you have a drug for blood pressure, say like you take a group of people and you measure their blood pressure, and then you give them this drug, and then after they've taken the drug, you test their blood pressure again. So for each person in the study, each individual, you have a pair of measurements. You have a before measurement, and then you have an after measurement. And so when you have data like that that's paired, use a paired t-test. When you don't have paired data, for example, say like you have one group of people and you measure their height, and we call that group A, and then we have another group of people and we measure their height and we call that group B, then we have unpaired data. And so that's when you use an unpaired t-test. And there are two subcategories of unpaired t-tests. One assumes that the variance within each group, so the variation around the height measurements in group A, is the exact same as the variation around the height measurements in group B. So they call that, well actually I don't know what they call that. They call that a t-test that assumes equal variation or equal variance. There's another type of t-test that does not assume equal variation. So you could have a different measurement of variance in group A as opposed to group B. Now, I often recommend that people select the test that does not assume that the variation is equal in both groups, simply because that test is slightly more conservative. And if your data can pass this more conservative t-test, then you know your data are rock solid. So I think that's my general recommendation for using t-tests. You go with, if you have unpaired data, go with the test that does not assume equal variance in both groups. Okay, now the second question people ask me is, should they use a one-tailed or one-sided t-test or a two-tailed or two-sided t-test? Now, a two-sided t-test, say for example, we'll go back to our height measurements. So we have group A and group B, and we've measured the heights in both groups. A two-tailed t-test would test to see if group A is higher than group B, and it also tests to see if it's significantly smaller than group B. So it tests both sides. It tests two conditions. So you've got a tail up here and you've got a tail down here. It's agnostic to the data. It doesn't have some preconceived notion that group A should be taller or group A should be smaller. It says, I'm going to test both sides and just see what group A is. A one-tailed t-test is a lot less conservative because it requires you to say, oh, I know which direction A is going to be. A has to be higher than B. And generally speaking, in academic journals, that's not a good way to go. Generally speaking, you want the data to speak for itself, and that's why I always recommend people use two-sided t-tests, because it's slightly more conservative, and it lets the data speak for itself. And again, the conservative thing means you've got rock solid data. So in summary, if you've got paired data, meaning you've got subjects, and for each subject, you've got two measurements. You've got a before and an after measurement. Well, then use a paired t-test. But if you don't have paired data, so you've got two separate groups of people, and you've measured everything, and there's not overlap between who's in which group. So if you've got unpaired data, use an unpaired t-test and try not to assume equal variance, because that'll make the test more conservative, and use a two-tailed t-test, because that makes the data speak for itself, and again, it makes it a little more conservative. So if your data can pass that test, you know it's rock solid. All right, that's all there is to it. Thanks so much for paying attention to this StatQuickie on t-tests.